Now here we're gonna do the question 7. The domain is where the function is defined. And we see that any polynomial here is well defined in all R. Therefore, the domain D is nothing else but the whole real lines. Or we can write it in this notation. D is from negative infinity to infinity. We're looking for the y-intercepts. At the y-intercepts, x would be 0. Therefore, f of 0 will be 0 cubed plus 2 times 0 squared, which is 0. And this is the y-intercepts. The x-intercepts are the points where the graph cut the x-axis. It means that we need to solve this equation. Okay, we see that this equation, f of x is, there's a common factor x squared. We factor it out. Inside will give us x plus 2 here, right? And the product of two things, we set it to be 0. Therefore, there are two solutions. X will be 0, or x plus 2 will be 0, or x is negative 2. So these are the y-intercepts, the x-intercepts. So there are two x-intercepts here. Okay. Now let us check if it is symmetric with respect to x, with respect to the axis or the origin. That helps us determine the graph better. Okay, we evaluate the value of negative x, which is negative x cubed here plus 2 negative x squared. The power of this is an odd number. Therefore, it will be negative x cubed. The power here is an even number. Therefore, it becomes 2x squared. Look at this. Here is 2x squared. Here is 2x squared. They are the same. But the first guy is x cubed. This is negative x cubed. Therefore, f of negative x is not the same as f of x. And we see that we know that negative f of x is actually negative of x cubed, which is here, negative 2x squared. Now, this times, we see that this guy is the same as this guy, but the second guy is not the same. Therefore, this guy is not negative of fx. It is neither f of x or negative fx. Therefore, the function is neither even nor odd. It means that it is not symmetric with respect to the origin or with respect to the y-axis. The horizontal asymptote, let x goes to infinity. We see that when x goes to infinity, the highest order here is x cubed, right? So a very big number raised to the power of 3 becomes a very big number, or we denote it as positive infinity. When x goes to negative infinity, a negative number raised to the power of 3 will be still a negative number, which is very large, and we denote it as negative infinity. So the vertical asymptotes are the solution, are the points when x approaches that point, f of x goes to infinity. And actually, there's no such point. So it has no vertical asymptotes. Okay. Now let us find the first derivative of the function, which is derivative of x cubed plus 2x squared here, right? Derivative of a sum would be a sum of derivative. Which give us 3x squared plus 4x here. Right. That's right. Very good. Now let us factor it out and see. When we factor it out, we see that x is a common factor. So this guy becomes 3x plus 4. This equation has two solutions. The first guy is at x is equal to 0. Or the second solution is negative 4/3. Right. So we fill in the blank here. The reason I make a table so that we can study it easier. X run from negative infinity to positive infinity. There are two solutions. The first one is negative 1/4/3. The second one is at 0. This is a quadratic function. And since we know the properties of this guy very well, I'm not going to do it in details, but let us write it here. F prime of x at the solution, F prime will be 0, 0 here. Between the two solution, the sign will be the opposite sign with a parameter of this guy, which is, and the coefficient of this guy is number 3, which is a positive one. Therefore, between these will be negative and positive outside here. Okay, which tell us that the function f of x here is increasing from this interval from negative infinity to negative 4/3. If it is negative, then it is decreasing. And again, if positive, it is increasing from 0 to infinity. So let us write some arrow here. It is increasing, decreasing, and increasing again. We see that this guy at negative 4/3, this reach a local maximum. And this guy at 0, it reached the local mean. Okay, we can fill in the blank here. F is increasing from two intervals. The first guy is from negative infinity to negative 4/3, union with 0 to infinity here. It is decreasing from negative 4/3 to 0. And it is clear that it is maximum here at this point, negative 4/3. Maximum is negative 4/3. Minimum at 0. At 0. At 0, y is 0 easy. at negative 4/3 here, y will be x cubed, which is negative 4/3 cubed, plus 2x squared, which is 2 times negative 4/3 squared. Okay. This gives us negative, what is it? Wow, it's big. 4/3, and here 3/3, and here, which is 2 times 4 squared divided by 3 squared. Then they don't have the same denominator. We can make them have the same denominator. Which is we multiply 3 and divide it by 3. So it means it becomes 2 times 16 times 3 minus 4 cubed, which is 32, and 32 divided by 27. Okay. Is it clear? Okay, let us continue. Let us find the second derivative. So we found that the first derivative is this guy, 3x squared plus 4x. Derivative of this guy, which give us 3 times 2 will be 6x here plus 4. Okay. Therefore, it has one solution. The solution will be negative 4/6, which is negative 2/3. At this point, f second derivative will be 0. Therefore, on the left-hand side, it will be negative sine of 6, which is negative, positive here. So on the left-hand side, we know that it is concave down. On the right-hand side, it is concave up. Okay. Therefore, it is concave upward from the interval negative over 3, 2/3 to infinity. Concave downward is from negative infinity to negative 2/3. And it has one inflection point here at the point here, negative 2/3. Okay, y will be negative 2/3 cube plus 2x squared, which is 2/3 squared here. And yeah, it's your job to find this, and let us find it. Okay, it is 8/27 negative plus, here it is 2 times 4 times 3 divided by 27, which is 24, right? 24 minus 8 give us 16. Okay, it will be 16/27. Now we have all the special values of this graph. We can sketch it. Okay. First, at axis, we have two y-intercepts, which is y-intercept is 0, 0, x-intercepts will be at 0 and -2. So the graph will go through this y-intercepts and the x-intercepts. There are 2 points, and we'll go through these points, okay? Anything else? Okay. Maximums at -0 and -4/3. Okay. Let us make it a little bit bigger. Let us find, okay. Here is 1, -1. Make it bigger a little bit, -2, 2. So the graph goes through these 2 points. Okay, and here is the local maximum at -4/3, which is this point. Oh, let me use a different color. When x is -4/3, y will be 32/27. Right, it is 1 point something, a little larger than 1. Okay, suppose 1 is somewhere around here, and this guy would be 32/27. So the graph goes through the point here. Okay. And the minimum point will be at 0, 0. This point, easy. Inflection point at -2/3. -2/3 will be somewhere around here. Okay. At that point, y will be 16/27, which is around 0.6. It should be somewhere here. Okay, it means that it goes through this point. Okay, very good. When x goes to -infinity, y will be very negative below here. It will go to this point, reach this point, and it go down, inflection point here. Right. What else? Oops. Suppose it's like this. And it turning here at this point, inflection point. And here we see that when x goes to infinity, it should go somewhere to positive infinity here, right? And let us find at 1, what is the value of y? When x is equal to 1, we substitute the value here, right? X is equal to 1, then y will be 1 cubed plus 2 times 1, which is 3. And if x is 1/2, then it will be 1/2 cubed plus 2 times 1/2 squared, which is 1/8 plus 2 times 1/4. Okay. It is 1/2 plus 1/8. Okay. Let us multiply by 2 and 2 here. It will be 5/8. Okay, you see, 5/8, it is a little bit bigger than 1/2 a little bit. At this point, 1/2 supposedly somewhere here, right? That is why this is 1, 2, 3, should has a point here. Therefore, the graph will be like this. This is f of x. x cubed plus 2x squared. Okay, that's it.